everybody. We're going to talk about tables of paired numbers, also called in and out tables or input-output tables. So we learned this, but we didn't spend a lot of time on this. So really focus when I'm talking to you about this lesson. So in a table of paired numbers, there's multiple steps that we have to do. So if you remember, a table of paired numbers is two numbers that come in as something, right? Or a number. Something happens in the middle and then they come out as another number, kind of like a machine, right? Comes in, something happens, comes out different. So your job is to figure out what the rule is or what happens in that middle part. Okay, so there's a few vocabulary words you have to know. You have to know what increasing means. Increasing means a number's getting bigger. You have to know what decreasing means. Decreasing means a number is getting smaller. Okay, you have to know the two steps that make numbers get bigger. So the two operations that make numbers get bigger are addition and multiplication. When you add, when you multiply, numbers always get bigger. The operations that make a number decrease are subtraction and division. When you subtract, a number gets smaller. When you divide, a number gets smaller. Okay, so here are the steps to a table of paired number. The first thing you should always do is look at the headings. And by headings, I mean the two labels at the top. Sometimes it just says in and out or input, output, but sometimes it gives you a clue as to what the rule might be. So some examples of that could be people and fingers. How many fingers do people have? People have 10 fingers, usually. Car, wheels. How many wheels does a car have? 4. So this rule might have something to do with 4. Octopus and tentacles. Dogs and legs. Most dogs have 4 legs. People and hands. Most people have 2 hands. Bike, wheels, 2 wheels. Tricycle and wheels. That's what you used to ride when you were a baby, right? 3 wheels on a tricycle. So those are some possible headings that your in and out table could have. Are there more headings that your table could have? Of course, there's a ton of different labels. So after we look at our heading to figure out if there's a clue, here it's bikes and wheels, so it could have something to do with the two. We have to ask ourselves an important question. On all the complete rows, you have to go to every single complete row and ask yourself, is it increasing or is it decreasing? Okay, so let's do that for our complete rows on our chart. So here we have people and fingers. So it could have something to do with 10. So I just put a 10 and a question mark. 2 to 20, is that increasing or decreasing? Well, I know that 2 to 20 is increasing. So I'm gonna put an arrow next to that row. Blank to 60, is that a complete row? Nope, it's not. So I can't look at that for increasing or decreasing. What about 5 to 50? Well, I know if I start at 5 and I go up to 50, that's another increase. So I put my arrow. What about 7 to blank? You don't know because it's not a complete row. And blank to 90, you also don't know. So we have 2 complete rows and they follow the same rule. They are increasing. So after you figure out increasing or decreasing, you have to figure out what operation could it be. So we know both of ours were increasing, so we're gonna look at the increasing one. We know we have to add or multiply. So somewhere on my table, I'm gonna write a plus, the addition sign, and the multiplication sign, because it could be either of those. Now, you know the one that we try first is always addition. We always try the addition first. So we're gonna ask ourselves, how do I get from 2 to 20 with adding? Well, 2 plus 18 is 20. Okay, so now we can't say that's the rule yet. We have to try all of the complete rows. 5 plus 18, is that 50? So let's see, 18, 19, 20, 21, 22, 23. 5 plus 18 is only 23. Does that match our table? No, it doesn't. So we know that addition cannot be our rule. So what does our rule have to be now? Multiplication. Has to be multiplication, right? So what we're gonna do is we're gonna try multiplication. We're gonna check all the complete rows, and then finally you fill in the table. So let's go ahead and complete those steps. How do I get from 2 times what equals 20? 2 times what equals 20? Well, let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh, 2 times 10 equals 20. Can I say that that's the rule yet? Not yet. I have to check all the complete rows. I have another complete row down here, so I have to try 5 times 10 and see if that equals 50. Is 5 times 10 50? Yes, so we now know that our rule is times 10. And look at that, it has something to do with our prediction. People have 10 fingers, right? So now our last step is to fill in the table. And that means any single thing that's missing. You can't leave any blanks. So in this table, how many blanks do we have? 1, 2, 3. We have 3 blanks. So if you look at this one's going backwards. So we have our outs, but we need to find our in. So what's the opposite of multiplication? Division. So we can say 60 divided by what? Or 10 equals what? Or we could say what times 10 equals 60. Right, it's 6. So our missing, the 6 people have 60 fingers. This row's good. Oh, here, this one's going forward. So we use our rule, times 10. So 7 times 10 equals 70. So 7 people have 70 fingers. Uh-oh, this one's going backwards again. So we can look at it either as division, 90 divided by 10 equals what? Or we can say, what times 10 equals 90? And that answer is going to be 9. Right, so once your in and out table is complete, you double check. 2 times 10 equals 20, increasing. 6 times 10 equals 60, also increasing. 5 times 10 equals 50, increasing. 7 times 10 equals 70, increasing. 9 times 10 equals 90, increasing. And then your in and out table is complete.